So these are the lesson five questions on the lesson sheet handout. This is not the homework. This is just the handout that I gave you, and you can see the answers. You can see the answer key. But I thought maybe I could, if you didn't really understand the answers on the answer sheet or on the lesson sheet, the answer key, I could go over how did I get these answers. Okay. So the first question says a bag of M&M candies. Inside of it is there's 7 blue and 3 red and 5 green and 2 yellow and 4 brown and 6 orange. Okay. And what we want to know is, well, what's the probability of choosing a blue M&M? And we're assuming that we're just first opening the bag. So we first open the bag. What's the probability of choosing a blue M&M? Well, this is very similar to the Skittles problem that we did in the lesson, okay? So the first thing we need is we need the total number of candies, okay? So total number, okay? We need the total number of candies, which is 7 blue plus 3 red, so 7 plus 3 plus 5 green and 2 yellow, 5 green plus 2 yellow, okay? 4 brown and 6 orange plus 4 plus 6, okay? If we add this together, 7 plus 3 is 10, plus 5 is 15, plus 2 is 17, 17 plus 4 is 21, plus 6 is 27. So the total number of candies is 27. Therefore, the probability of choosing a blue M&M, since there are 7 blue M&Ms, the probability is 7 out of 27, okay? Now we can do that in the calculator and turn it into a decimal. So if we go to the calculator and do 7 divided by 27, we get 0.2592, but we're going to only go to 0.259, okay? So that's a pretty good probability, 0.259. That's like more than a fourth of the bag is just blue M&Ms. What's the probability of choosing a red M&M? Well, there's 3 reds, and so it's going to be 3 out of 27, okay? Which is the same thing as 1/9, but we're just going to key it in as 3 divided by 27. That's just 0.111. 0.111. Okay, great. Choosing a green M&M. Probability of choosing a green. Well, there's 5 green M&Ms out of a total of 27 M&Ms. Therefore, the probability is going to be 5 out of 27. And we can key that in as 5 divided by 27. And that's 0.185. 0.185. Okay. How about the probability of choosing a yellow M&M? Yellow, there's 2 yellow M&Ms, so it's going to be 2 out of 27. So we're going to go 2 divided by 27. That's 0.074. So 0.074. Probability of choosing a brown. There's 4 browns, and therefore we're going to say that it's 4 out of 27. And if we want the decimal, we can do 4 divided by 27, which is 0.148. 0.148, which, by the way, is double 0.074. And so because 4 is double 2, okay, so that makes sense. So how about choosing an orange? Well, there are 6 orange M&Ms, so it's going to be 6 out of 27. Now note, 6 is double 3. And so our probability here should be double the probability of 3. So 0.111. My guess is that this is going to be 0.222. Let's make sure. 6 divided by 27, sure enough, 0.222, okay? All right, let's move on to the next question on this lesson 5 practice sheet. All right, it says when a car gets a flat tire, there's usually a single cause for the flat tire. It's not like 2 things happened at the same time that caused the flat tire. It's usually just one thing caused the flat tire, okay? One of those things is getting a screw punctured in the tire. In fact, it's funny, right now, my car has a screw that has punctured one of the tires. The tire's not flat yet because sometimes the screw goes in and it just sort of plugs up the hole. And if you leave it alone, you might be able to drive around for a little while on it. But the probability of a screw puncturing the tire is 0.47. The probability that the inflation valve where you put the air in, that it was damaged, meaning there's air coming out where the air goes in, is 0.15, okay? And this is saying, well, what's the probability that a flat tire is due to either a screw or a damaged valve. And so what we're saying here is, what is the probability that the flat tire happened because of a screw or a damaged valve? Okay, and all we have to do here is add together the two probabilities, 0.47 plus 0.15. Okay, and so 0.47 plus 0.15 is 0.62, and so the answer here is going to be 0.62. And then part B says, well, what's the probability that a flat tire is due to some other cause? Other cause, not a screw, not a valve, okay? Well, we know that the total probability is equal to 1, and if we take away the probability that it's a screw or a valve problem, which together is 0.62, well, 1 minus 0.62 is 0.38. So that the probability that it's some other cause is 0.38. Okay, let's move on to the third one. All right, so you can see we've got this discrete probability distribution right here, and like I said, we're going to talk about those in chapter 4. So the discrete probability distribution of a student's major at one particular university is shown below. Okay, now we're assuming that none of these students have more than one major, that they're picking just one single major. Okay. And what this is saying is that 0.11 of the students are psychology majors, 0.19 of the students are education majors, 0.23 of the students are science majors, 0.13 of the students are engineering majors, and all the other students, the other 0.34, are some major other than psychology or education or science or engineering. Okay? So what is the probability that a randomly chosen student is not an education major? So what we're essentially saying here is, what is the probability that any student is not an education major? Okay. Well, the probability that they are an education major is 0.19. So if they're not an education major, then they're either psychology or science or engineering or other. So there are two ways of doing this. We can either add up 0.11 plus 0.23 plus 0.13 plus 0.34, or we can do 1 minus 0.19, which is 0.81. Now notice, if we add these up, 0.11 plus 0.23 is 0.34. Plus 0.13 is 0.47, and plus 0.34 is, sure enough, 0.81. So the probability that a randomly chosen student is not an education major is 0.81. What about the probability that a randomly chosen student is either one of two things, either a science major or an engineering major? So this is the probability of science, that they're a science major or that they are an engineering major, okay? And that probability is, we're just going to add the two probabilities together. Probability of science plus probability of engineering. 0.23 plus 0.13, which is 0.36. And so that's our answer. Okay? Let's go on to the last one on this lesson sheet. All right, this says that many adults older than 30 were asked, what kind of vehicle did you have as your first vehicle? The probability distribution for their responses is given below. Now, they're split up. Every single vehicle is included here, okay? But there are 4 categories that were highlighted: a 2-door car, a 4-door car, a 2-door pickup, or a 4-door pickup, okay? And then we have this other category here, which is some other car. Like, I knew a guy who had a hearse as his first vehicle, and that's none of these other vehicles. I mean, technically, I guess you could say it's a 2-door car, maybe a 4-door car, but it's a hearse. It's different. Some people might have had a motorcycle as their first vehicle, and so that also would be other. But there are some people who have never even owned a vehicle before, and therefore they would select none. But the fact of the matter here is that every single adult over 30 can be classified in one of these 5 categories. And the probability that you randomly select a person and their first vehicle was a two-door car, that probability is 0.27. The probability of selecting somebody and their first vehicle was a four-door pickup truck is 0.08. So we want to know, well, what is the probability that they had a car as their first vehicle? Well, a car would include both a two-door car and a four-door car. So all we would do is add together 0.27, so 0.27 plus 0.35. If we add these together, that's all of the cars. And so that's 0.62. 0.62. All right, what's the probability that they did not have a two-door vehicle? So we'd want to leave this one out and leave this one out, okay? And so then this is not a two-door vehicle, this is not a two-door vehicle, and then these over here, they didn't have a two-door vehicle, okay? So we're only gonna include the four-door, and then the none or other. Add those up, we get 0.12 plus 0.08 is 0.2. 0.2 plus 0.35 is 0.55. 0.55, okay? What is the probability that it was not a car? Well, there's a couple ways of doing this. We know that the probability that it was a car is 0.62. The probability that it was not a car is just simply going to be 1 minus 0.62, which is 0.38. But another way to do not a car is to take the two-door pickup, not a car, the four-door pickup, not a car, and the none or other, not a car, and add those together. 0.18 plus 0.08 is 0.26. 0.26 plus 0.12 is 0.38. Last one. What is the probability that it was not a four-door pickup? Okay, well, there's only one category that's a four-door pickup. So as long as you're not in that category, you're good. So we're going to include this one, this one, this one, and this one. So it's going to be 0.27, 0.27 plus 0.35, 0.35 plus 0.18, 0.18 plus 0.12, 0.12. Well, 0.12 plus 0.18 is 0.3. 0.3 plus 0.35 is 0.65. 0.65 plus 0.27 is 0.92. Therefore, it's 0.92. The other way you could do it is you could just do 1, that's all of them, minus the one we're leaving out, minus 0.08, which is 0.92. Okay? All right, well, hopefully that helps you understand this lesson sheet and these probability questions, and you're ready to go on to even bigger and more complicated probability questions.